So, Serj, the stage is really yours.
Hi everyone, I'm Serj Smorodinsky, and let me share my screen. Okay, so we're going to talk about agentic systems. That's all the rave about for now. Problem solutions and human psychology. The last part is the most exciting thing for me. Now, before I start, I want to say that this is, even though it's sort of a monologue, but feel free to participate in chat, interrupt me, however you want. It's uh, it's light mode. I'm not putting a lot of formulas. It's more high level, and I feel that's the most appropriate thing, like to view these things from a high level first. Great. So, um, something that I do in the courses that I teach is that I show an image and then I ask, what is the prompt that created this picture? So just think about it for a minute. Oh, wait. Sorry. No. Okay, so I mistakenly showed you the answer. So the prompt is create me a picture to illustrate that unfortunately agents are too similar to humans. And this is a theme of this presentation. I'm going to show you problems that both agents and humans have and solutions that we can kind of borrow from each of the fields. One of the interesting things, for example, that I see happening is that as engineers are working more and more with AI coding tools like Cursor, ChatGPT in the usual way, they start documenting their code better and they starting to give more and more context. As a side effect, other engineers enjoy that. So now juniors get to see more context, and this documentation first approach is kind of happening in reverse. Even though we should have done it, but now that we are working with agents, it's obvious that we need to, even though we always had to. So we can kind of borrow from both perspectives. Okay, so one of the main problems is overconfidence. Basically, we all know that LLMs are and agents are eager to help, eager to solve, eager to answer, and also some of the humans that we're working with. So one of the signs of experience is underestimating how much time it will take you to do a certain task. And humans are notoriously bad at it. It's not only in the engineering paradigm or methodology, it's everywhere. It's very hard to estimate the task. It's is only if you've done really something very similar to that you're able to, in a way. So that's a problem that both sides have. And if there's a slide that you kind of like the main slide of this whole presentation are the four main challenges we have. Just a second. Yes, sorry. The four main problems with current agentic flows. I use agents and LLMs interchangeably. You can in some cases. But problems number three and four are mostly with agentic systems. LLM-based workflows tend to be somewhat short, but it isn't interchangeable. And we'll talk about definitions of agents in a minute. So the four main problems are hallucinations, over-eagerness, as I've shown you, keeping attention across long tasks, and having short memory, not learning from experience. And what I'm trying to bring in the current presentation is showing you that the best current solutions to solve these challenges kind of borrow from human psychology best practices, which I find really awesome. So if you're a software engineer that is interdisciplinary and you have worked a little bit on and you have a breadth of learning a little bit about the mind, psychology, you might have an edge in figuring out how to work with LLMs a little bit better. Also, if you have an educational background, that can also help. So that's kind of surprising that it can really help you in these days. I'm Serj Smorodinsky, and now it's the time to introduce myself. I call myself the friendly ML architect. And because I'm friendly, I'm approachable. Feel free to send me any questions. I do a lot of sessions on finding first DS entry positions. I try to help people find their strengths and kind of work with them. I also create tons of content on LinkedIn, on YouTube, and feel free to follow me. And of course, I'm teaching at Y Data, and also I'm working at Loris as a team lead. Great. So now we've talked a little bit about the similarity between agents and humans. Great. Let's do the basics. So what are agents? We can look at like the etymology of the word agent, and it's derived from basically agency. So you can see it two different definitions of an agent. The right one is really like legal, a person legally empowered to act on behalf of another person or an entity. So that's what we are seeking from our agents, to act on our behalf. So whenever I mention agents, it is a mechanism, a system that has some interaction with the environment. It has tools, memory, and planning to achieve a certain user goal. Any questions so far? Feel free to send it in chat or just stop me. The kind of intro way to implement an agent, the basic pattern is React, which is reason and act. So basically, there's an input, then there's a thought of the LLM, like it will break down maybe whatever it needs to do. Then it will choose an action. Action is usually a function or a tool within a subset of the tools that the agent is exposed to. Then the function of the tool is executed, and the agent gets to see what happened. That's the observation. And you kind of do it. And of course, the observation is new data, and there's a new thought, and so forth. So it's like while true until the task is completed, or we're out of steps or out of money, which can happen with the modern systems. And so on the left is like the whole flow of React. On the right is just like system action observation environment as a summary. Why do we need agentic software? Basically, because the environment is dynamic and it's complex. If everything could be predetermined, we would just write everything in code with lots of if-elses. If a task cannot be if-elsed, it means that we need some sort of an agent. And here's an example of a very simple scenario that is quite complex when you imagine the actual number of steps you need to do. And it's just to make a breakfast. So you need to look for the correct thing, like for the cereal. Then you need to look for the milk. The milk might run out, and then you can get upset and drink the milk instead of eating the cereal, which is an odd choice. But still, there are like tons of decisions you need to do in your everyday life. This is somewhat similar to the amount of decisions you need to do when you order something online, when you're browsing, because there are lots of changes, the UI changes, the goal might be weird. For instance, if you try to order something and you got to an error, do you need to retry? Do you need to like stop? So a lot of things are kind of undetermined, and that's where agents shine. Here's an example from a more formal, like a known problem. Aleph, I call it Aleph World. I don't know exactly how to pronounce it, but basically it's somewhat similar to the task of eating cereal. There is a description, you are in the middle of a room, and your task is to get something or to open something, and you are in this weird space that only contains furniture. It's a very it's an odd environment to dream about, but it's very formal, so you can kind of recursively try and solve it, and there are formal solutions to this case. But why from where does arise the complexity is that you're searching for a vase or you want to put the vase in the safe, but you're not sure where the safe is, so you need to find it. And you're not sure where are the rooms, so you need to enter each room and so forth. So you need to do a lot of decision making. Actually, during my studies, we had to code a recursive solver for this thing. In real world, like when you code or when you browse the internets, it's much more chaotic than this. Still, Aleph World is one of the benchmarks that agents practice on. Okay, now to problems. So first problem is hallucinations. Because models are eager to please, they can try and calculate whatever you throw at them, which is sometimes not the best and not the best strategy. Even humans, we tend to kind of answer immediately without thinking through. So we kind of share this eagerness to answer. And of course, the solution is using external tools. So I wouldn't ask a human to calculate in his head uh, 213 by 312, which is 66, 5 for something. No, I would use a calculator, or I would do it by hand, but actually learning rules like how to add and multiply by hand with like a scratch pad, that is something that is kind of hard to learn. Um, Whenever LLMs need to learn strict rules, that's where kind of things fail. So one of the ways to kind of circumvent that is writing programs. So the best way now is to do something complex, is write a program, and the program will calculate it for me. And there are external APIs. So for instance, I don't know what is the weather in Paris. I shouldn't guess about it. I just can use an API. So by plugging tools, that was one of the ways that LLMs got now like a lot of new powers and much more accuracy. One of the benchmarks and one of the things that providers worked on is on improving tool calling. So it's an actual benchmark and it's a task that LLMs train for. Another problem, models have a cutoff date. Um, they have a cutoff date, they're trained up to a point, so they don't know what's going on right now. And this is logical. Things always changing. In a similar way, models are not aware of your company's data, right? They are not trained on private information, hopefully. And we need to bridge that gap. So I can't expect an agent or an LLM to know something that it has no way to know. And the solution is retrieval system. Just as a human getting calls from a call center, he has been trained on a certain knowledge base of cases that customers can call to. Similarly, a chatbot has a knowledge base that it can query dynamically to get certain relevant pieces of information. And number three on hallucinations, hard facts from memory. By the way, who remembers on which dates World War II started? Let's see if somebody remembers. It was just a couple of days ago, and a lot of years ago. It was on the 1st September. That's the official date. So there's a new research, just like a paper that was released kind of a week ago, I think, of trying to prove the potential of hallucination based on the query. So the more information I give in my request, the less chance that I will have a hallucination, but up to a point. This paper shows an interesting formalization of the number of important bits that a certain query must have in order to decrease hallucination rate to, I don't know, 10 or 5%. So there are lots of innovations on trying to calculate what are the odds of hallucination. Where's the draw from human psychology? Well, it's kind of best practice to give more context to things. So I can ask very vague questions and I can ask very specific. And it's kind of intuitive that a certain detail, that in order to get a quality answer, for instance, well, Serge, how much time will it take to build a new web server? I don't know. Well, I kind of gotta get more details in this question. For instance, how many requests does it need to serve, and so forth. So if I would just answer something without this information, it's kind of similar to hallucinations in a way. So, sir, so whenever we're asking LLMs or humans, please provide the important bits. And on the side of eagerness, so the more time LLMs spend thinking, and the more time at to a point that also human think, we kind of improve the quality of the answer up to a point. Please don't take me literally. So formally, this is called test time scaling. It's a new approach in training reasoning models, but also it's an overall arch of lots of different methodologies of using kind of more of the inference time of the model. The first one was chain of thought. So instead of like asking a question and getting an immediate answer, we prefix the answer with let's think step by step. And it's got so infused everywhere that it's kind of a second nature to us, and that's why reasoning models already use it in even before answering something. It's part of their mechanism of like thinking. And so we are kind of used to using scratch pads when we're trying to solve complex stuff. We are drawing diagrams when we need to. All of that kind of borrows from the same idea, using more time and more resources to answer complex questions. And from the different methodologies that I've seen, this one is one of my favorites, and it's very intuitive when you think it through. So one of the ways to kind of improve your answer is asking additional questions. And I cite a very uh, an awesome paper that I like. I love to bring to mention it. But first, uh, here's an example of deep research by OpenAI. Nowadays, deep research is like a common name for features that behind the scenes an LLM or an agent does a lot of things and then gives you a very thorough report. Something that like 2 years ago didn't seem achievable at all. At first, GPT-3 was giving, and GPT-2, one of course, were giving very shallow answers. With time, the answers became much more deeper, even like giving out Wikipedia-like articles. So how do they do it? In order to increase the kind of the context of the problem, there's an internal process of question answering. That's one way to implement it. Another way is just asking the user. So that's what deep research for OpenAI, for example, does. So before I begin the research, could you clarify if you would like a comparative analysis or structured or yada yada yada? If you've used the feature, you kind of know that you will be
Mm.
asked upon several things, which makes a lot of sense because,
תמשיכי.
sorry,
את יודעת מה? קודם תתרחצי, ואז תמשיכי.
זה תמיד הדבר הנכון. אוקיי. So here I'm borrowing from a paper called Storm by Stanford. It was released much prior to deep research by OpenAI, and they were already kind of exploring question answering, but through self Q&A. You can see on the right that there's a prompt. Ask 30 questions about the given topic. And the topic is the Olympiads or something like that. So by asking this, you get like when, where, how many, what questions, which are kind of shallow. But on B and C, you can see a different approach. So for B, they give a perspective. You are an event planner who focuses on preparation. This already deepens kind of the questions that you can get. And you can draw lots of perspective. You don't have to kind of use only one. So let's say you have 5 or 10 perspective, you can already get a lot of very deep questions. And of course, there's conversational question asking. This is very useful because usually questions lead to additional questions. And you never know where you land exactly. And this is how you get wisdom, basically. So, effective question answering is crucial in information acquisition. Also, I love this like short thing.
That's the thing. You have to ask yourself a question. That's hard enough to actually ask. You have to wait for the answer. Then you have to assess the answer critically, which means that you have to divide yourself up into 2 or 3 people, each of which has a different opinion, and have them argue about something, like in the theater of your imagination, to assess the idea. That's hard. So normally what we do is we talk to other people, or we stay muddle-headed and confused. So listening is half of thinking.
Yeah, so Jordan Peterson said it best. In order to gain wisdom, we need to talk either with ourselves or with other people. Stop. Thank you. Okay, how do we fight the loss of attention across long tasks? So, first of all, why do we have long tasks? In complex environments such as coding, when you're not sure exactly what will be the output of whatever code you have written, you can do multiple sessions of debugging, changing the code, and so forth. So it's a complex environment that you can't really predict what's going to happen. If you could, but you can't, because that's the halting problem, side quest. But if you could, of course, it would be much faster. So in these environments, you get long tasks in coding and web browsing, basically. And also in scientific research, whenever you need to do experiments. So there are a lot of ways to kind of help with that. One of them is creating subtasks. Subtasks is meaning splitting the task into different perspective in order for each agent to specialize in one thing. If the agent kind of receives less responsibility, there are a lot of good things that come out of it. First, you kind of test it. You can test it independently from the other agents. That's good. Other than that, it needs less context. It needs less tokens, less output, and so forth. So one of the first things to do is to cut a big task into chunks of small tasks. In the case of the storm article that I've shown you, so there are different agents for like there's an agent or an LLM task for deriving perspectives. Then there are agents who ask things, there are agents who answer things, and not all of them get to see all of the context of all of the other tasks that were so far. There's another very intuitive approach. So if I need to, if I have a question, and let's say I have a book, or maybe I have a question on NBA, which team does the player named Diamond Head Classics MVP play for? And I might have like tens of Wikipedia articles. A good way to tackle this is giving a chapter or a Wikipedia article for each different agent, and then looking at their answers and trying to figure out if there's maybe a majority, or trying to figure out condition of the text who was correct. So this kind of approach of basically segmenting the data makes a lot of sense. And this is another article, it's called Long Agent. The premise of the article is how to work with long chunks of text, like books, for instance. Great. There's another approach to helping with attention across long tasks. There is intermediate summarization. So whenever I have lots of steps, I can try to summarize what happened so far, and then lose all the things that happened before that, and kind of condense the context. Here's a quote from Anthropic's Deep Research article. So that's actually what they're doing. They're doing it within regular like web talks, but also with deep research. So it's called Long Horizon Conversation Management. So we implemented patterns where agents summarize completed work phases and store essential information in external memory before proceeding to new tasks. This is again somewhat intuitive. We do it all the time. We have Jira tasks, we have notebooks that we write whatever happened. So by providing similar strategies to our agents, to our LLMs, they can improve. And here's one of the latest articles. Like these things change so much and so frequently. It's really hard to kind of follow along. But from time to time, there are just papers that you know that they're really good. One of those is called Memento. And here's like I took an image from the movie Memento. Whoever seen it, great. I'm sure you had a lot of fun. So Memento is about a guy that each day he forgets all the things that happened to him up to a point. Like he remembers that he had this accident, and he's investigating the death of his wife. And he writes all of the things that happen to him day to day. He can't really create new memories. So he's tattooing on himself like new information, and he's writing in notebooks, and he has these notes, and it's a cool movie. Well, basically, that's the that's the life of LLMs. They wake up in each new request like fresh, without no memory, without anything. So the paper is about how to improve that. Uh, Behind the scenes, after training, LLMs are frozen. It means that their weights are not changing anymore. We can change their behavior through prompts, of course. So they are dynamic in that approach, but still, if the weights don't change, the fundamental behavior doesn't change as well. Like there's no learning outside of the tricks that I've shown you. So you can summarize, put it in the prompt, you can put it on files, whatever. But still, it's not as effective if we could allow some continual learning. On the other side, humans, we animals, we do learn from experience. We learn all the time. We're creating new memories. We're creating things, especially if they are attached to emotional things, by the way. So We are continuous learners. So how can we achieve that with LLMs? Sorry, let's keep this slide. So in order to continuously learn, the Memento paper proposes an external neural network, another one. We keep the LLM frozen, and we have this external module that is trained over time and retrained. And its goal is to retrieve the best memory to help you achieve the goal for your current task. So it's a training with reinforcement learning. It learns a policy on how to retrieve a memory. And the memory contains the tool that you've used, the prompt that you've used, and the third thing that I don't remember. So basically, memory contains all the decisions that happened to something and the reward you got. How good was the result? So by training this external module, which is somewhat similar to what kind of happens in our mind as well, because we are different compartments in our mind. There are some things that responsible for decision making, like the frontal lobe, and there are memories in the hippocampus. So I can see like some inspiration from just the anatomy and the functions of the brain, and actually the article writers do mention some inspiration from the brain. They call it as episodic traces, and also selectively reinforced by dopamine-driven credit assignment. So you can see there's a lot of inspiration that is drawn from like neurology and psychology. We all love dopamine. And then there's another lightweight approach to memory. We can try and summarize the things that happened so far and kind of put it in a box and then try to just use that box when you need to. There's a lot of ways to do it. There are open source libraries and memory as a service providers like MemZero. So in this instance, there's this conversation, and the agent remembers, like, points to itself, oh, I need to remember this fact or that fact. They have a great example of somebody asking for a recommendation for a vegetarian restaurant, and a day after, it asks for a dinner, but it doesn't mention that he's vegetarian. So because the agent kind of pointed to himself that this user is vegetarian, the agent proposed vegetarian restaurants. It's a very like day-to-day example, but these things happen all the time. And whoever practiced coding with AI agent assistants, it's really frustrating that there's no learning from task to tasks. So I found myself trying to explain the like 500 times on the kind of format rules we're using, that you shouldn't create like long tests and stuff like that. So cursor rules, for instance, whoever used cursor is a way to kind of control what cursor learns about you, but you can also create a proactive approach of asking the LLM while it's working, okay, what is an important fact from this, and please save it somewhere, and then retrieve it. The actual retrieval naively can be used with semantic similarity. Just as retrieval engines work with different tasks, memories can also be selected via semantic similarity to the current task. We're almost about to finish. I hope I didn't bore you to death. Uh, Currently, we are in a transition period. It's so exciting to be in this field, and even just watching it change so rapidly. So the transition is from system 1 to system 2, not from system 2 to system 1. Uh, so our current machinery, our current LLMs, deep learning they are very like System 1 in humans. System 1 is responsible for very fast and pattern matching like responses. So whenever you drive, you're using System 1. Your goal, whenever somebody asks you something, is to use System 2. And some of us, for some of us, it's harder because System 2 is more critical. It looks at System 1 results and says, you know what, take some time. Maybe your task won't take like 2 hours. Maybe it will take a day. So that System 2 like kind of kicks in. So we're seeing this transition when these very eager, pleasing machines kind of transition to more slow and deliberate planning and reasoning machines. Summary. I'm really hyped, and I think now is the best time to enter the field. And there's a lot of positive potential. I do believe in multidisciplinary people, they're going to change the world. Another point I want you to take home is that treat your agents as you would treat your peers if you treat them well. And please treat your peers as if you would treat your agents if you treat them well. Because what I'm seeing is a lot of effort that is spent on helping agents um, be more effective, while some humans left kind of aside. Our peers, our colleagues, the people who are less experienced that need our advice. So please be attentive to humans at least as you are attentive to agents. And of course, the classical all models are wrong, but some are useful because even as we progress, models will tend to error. And we need to build systems that are critical. Even though they are wrong, they will still we need to find a way to make sure they are reliable, and that's the main focus of like in the industry. So you're not looking at things only from a research standpoint. You're thinking what is useful, what can be scalable, and what can be effective. Thank you, everyone.
Thank you, Serj. Any questions?